Hello and welcome. Today, we are going to dive into an important algebraic technique called factorizing by grouping terms. But before we get started, let's think about something practical. Have you ever tried to simplify a complicated expression or equation? Perhaps something like a polynomial with several terms, where it seems hard to find a common pattern. Well, that's where factorization by grouping comes in. It's a method that helps break down complex polynomials into simpler, more manageable parts, making them much easier to work with. Now, let's start by understanding the concept. Factorization is the process of expressing a mathematical expression as a product of its factors. When we apply the technique of grouping, we look at the terms and group them in such a way that each group has a common factor. For example, consider the expression 4x squared minus 10xy plus 6x minus 15y. We'll see how we can break it down into smaller parts, identify common factors, and simplify the expression. Alright, let's move on to the first step. The key here is to rearrange the terms in such a way that we can group those that share common factors. Let's take our example, 4x squared minus 10xy plus 6x minus 15y. We'll group the terms as 4x squared minus 10xy plus 6x minus 15y. Notice that in the first group, both terms have a common factor of 2x, while in the second group, both terms have a common factor of 3. Rearranging the terms like this helps us identify the common factors more easily. So far, we've grouped the terms into two pairs. Now, let's factor each group. Starting with the first group, 4x squared minus 10xy, we factor out 2x, giving us 2x times 2x minus 5y. For the second group, 6x minus 15y, we factor out 3, so we get 3 times 2x minus 5y. Now we have 2x times 2x minus 5y plus 3 times 2x minus 5y. At this stage, you can see that both terms now have a common binomial factor, 2x minus 5y. So far, we've successfully factored each group. The next step is to factor out the common binomial term from both parts of the expression. Since both terms contain 2x minus 5y, we can factor it out. So, we get 2x minus 5y times 2x plus 3. And there we have it, the completely factorized form of our original expression. This is the power of grouping terms and factoring them step by step. It's a systematic approach that breaks down complicated problems into simpler parts. Let's try another example to see how well we've understood the process. Consider this expression, x cubed plus 2, x squared plus x plus 2. Again, we start by grouping the terms, x cubed plus 2x squared and x plus 2. Now, let's factor each group. In the first group, x cubed plus 2x squared, we can factor out x squared, giving us x squared times x plus 2. In the second group, x plus 2, we can factor out 1, so we get 1 times x plus 2. Now we see that both parts have the common factor, x plus 2, so we can factor it out. X plus 2 times x squared plus 1. That's our fully factorized expression. This example demonstrates the simplicity of the method, even with more terms involved. Let's tackle a slightly more complex example. Consider the expression xy minus pq plus qy minus px. We start by grouping the terms xy minus px and qy minus pq. Now let's factor each group. In the first group, xy minus px, we factor out x, giving us x times y minus p. In the second group, qy minus pq, we factor out q, giving us q times y minus p. Now we can see that both parts have the common binomial factor, y minus p, so we can factor it out, y minus p times x plus q. This demonstrates how grouping and factoring work for more complicated expressions as well. You can always look for common patterns to make the factorization process easier. Alright, let's quickly recap what we've learned today. Factorization by grouping involves three simple steps. Rearrange the terms and group them in such a way that each group has a common factor. Factor each group by taking out the common factors. Finally, factor out the common binomial factor from the groups. This method works wonders when dealing with polynomials that can be grouped into smaller, more manageable parts. Now that you have a good grasp of how factorization by grouping works, you can apply this technique to more complex problems with confidence. I hope you now understand how this method helps simplify algebraic expressions. In the next video, we will explore difference of two squares, another essential concept in algebra. See you in the next topic.